Hey everybody, today we're going to be proving the chain rule of differentiation, which as you can see we have ready, and we're going to derive that formula using implicit differentiation. So how are we going to do this? Well, what we're going to start with is we're going to say y, just a random y, is equal to f of g of x. Alright, so we could say this is y of x, or we could call this h of x, or something else, but I'm just going to call it y, just for simplicity. Okay? So we're taking dy dx, essentially. Okay, so what do we do now? Well, we can take the f inverse on both sides and kind of get rid of the, composition of functions thing. I can speak. And so yeah, we have f inverse of y equals g of x. So the composition of functions is gone. Now what? Well, we have to take the derivative on both sides. This is easy. This is just going to be g prime of x times dx, basically. What about this? What's the derivative of f inverse? Let's just do that separately. So I'm going to do that. I'm going to do that down here, actually. Actually, I'll do it up here. So we're going to take the derivative of f inverse of y. Alright, actually this is going to be a dy because we're doing it with respect to y. Okay, so let's do the same thing we did up here, and let's set like something like z equal to f negative 1, or f inverse of y. Fairly standard. We can take the f on both sides, we get f of z equals y. When we take the derivative now, this is going to be f prime of z. But we're forgetting something. Always remember the dz at the end. That's going to be equal to 1 times dy. Alright, so now what we need is dz dy. So dz dy is equal to 1 over f prime of z, but remember we're doing this in terms of y, so z is just f inverse of y. F inverse of y. And that is our derivative of the composition of functions, and we're pretty much done basically. So all we need to do is plug everything in. So this is actually in terms of what we need, so that's good. So we get 1 over f prime of f inverse of y. Right? F inverse. There we go. And that's going to be. But remember, we need the dy. We're kind of making this dz because we're going to get the dx here, so we're going to need the dy. So I'm just going to put it, I'll actually put it at the end here, so we get dy, and that's going to be equal to g prime of x dx. So now what? We need to isolate dy dx, so what we're going to do is we're going to multiply this across, we're going to divide by dx, so we get dy divided by dx, right? So we divided by dx, and that's going to be g prime of x, and since we're dividing here, we're just going to multiply, get times f prime of f inverse of y. But what's f inverse of y? Well, that's g of x. F inverse of y is g of x. So at the end, we get dy dx being equal to g prime of x times f prime of g of x. And that's it. That is our chain rule. Very, very straightforward. It's just g prime of x times f prime of g of x. And that's it. That's how we get it. All we need to do is use implicit differentiation, and it's very easy. I'm not sure if there's a way to do it using the limit definition of derivatives. I can't really see that, but like, there might be. So if there is, I'll make a video on that eventually. But yeah, that is the derivation of the chain rule.